In this presentation, let us see why Cj minus Zj is less than 0 in a tabular simplex method. So whenever a linear programming problem is given, we try to solve it using tabular simplex method. We first convert the problem into standard form, and then we use iterations to maximize or minimize the function until Cj minus Zj is less than or equals to 0. We compute all the iterations and we try to find the optimal solution for the given problem. So let us see why Cj minus Zj is less than 0 using a question using algebraic simplex method. So whenever a problem z equals to 3x1 plus 4x2 is subjected to some constraints, we first convert the linear programming problem into standard form by introducing slack variables. Here the maximum value of z is given by 3x1 plus 4x2 plus 0 into s1 plus 0 into s2. Here s1 and s2 are the slack variables. These are added to the constraints because the left hand side of the constraint is less than the right hand side of the constraint. Here the left hand side of the constraint is less than the right hand side of the constraint. So to equalize the left hand side and right hand side part, we just added a positive value. A positive value is added to left hand side to optimize the equation. So S1 and S2 are added to the constraints so that we can get a equality constraint. So here x1, x2, s1, s2 are greater than or equals to 0. So let us try to maximize the function z from scratch. Given max z equals to 3x1 plus 4x2 plus 0s1 plus 0s2. The maximum value of z depends on x1, x2, s1 and s2. Even though s1 and s2 are independent, whatever be the value of s1 and s2, max z value remains same. So x1, x2, s1, s2 greater than or equals to 0. Let us find the minimal possible value of z. So the minimum possible value of z occurs when x1, x2, s1, s2 equal to some value. Let us consider x1 and x2 equal to 0, as they are always greater than or equals to x1 and x2 equals to 0 be the initial minimal value for the given constraint. So when x1 and x2 equals to 0 and s1 and s2 can be anything. So when x1 and x2 equal to 0 and s1 and s2 be anything, the value of z will be 3 into 0 plus 4 into 0 plus 0 into something plus 0 into something. So the value of z is 0 is the minimum possible value for z. So here x1 and x2 are equals to 0 and s1 and s2 can be anything. Minimum value of z is 0. So let us try to maximize z from 0 until the above two constraints are satisfied. So let us take the first iteration 1. Let us consider s1 and s2 be basic variables. So when s1 and s2 are the basic variables, we write the constraints in terms of s1 and s2, like s1 equals to 6 minus x1 minus 2x2 and s2 equals to 12 minus 3x1 minus 2x2, and max z equals to 3x1 plus 4x2. As we know, the minimum possible value of z is 0. Let us try to find let us try to increase the value of z from 0. So increasing the value of z based on x1 will be 3 times, and increasing the value of z will be 4 times if we increase the value of x2. So the rate at which z increases will be high based on x2. So let us try to maximize x2 first, because the rate at which z increases is 3 for x1 and the rate at which z increases is 4 with respect to x2. So let us try to maximize the value of x2 from 0. So x2. So here the maximum possible value of x2 is 3. As we know, if we place the value 3 here and 0 here, this will be 6 minus 6. So s1 will be 0. The least minimum possible value of s1 is 0 according to the constraints. So the maximum possible value of x2 is 3. Here the maximum possible value of x2 is 6. So these two be the possible values for x2. But whenever x2 value is 6, the value of s1 will be negative. S1 will be negative. So s1 can't be negative. So let us consider x2 as 3. So the value of x2 should be 3. Here now if the value of x2 is 3, if the value of x2 is 3, then the value of s1 will be 0. So now x2 and s2 will be our basic variables. Let us try to compare the algebraic method using tabular simplex method. Here is the result for iteration 1 using tabular simplex method. Here the zj value is 3400. If we observe the value of max z, the values will be 3400. So the values here 3 4 will be the Cj minus Zj values, and the values 3 and 4 will be the minimum ratios according to the tabular simplex method. So let us try to write the iteration 2 for this method. So the iteration 2 for this method will be as we got x2 and s2 be the basic variables. Let us try to write the constraints using x2 and s2. So here the values will be x2 equals to 1 by 2 into 6 minus x1 minus s1, and s2 equals to 6 minus 2x1 plus s1, and max z equals to 3x1 plus 12 minus 2x1 minus 2s1. So max z will be 12 plus x1 minus 2s1. So let us check if we can further maximize the value of z. If we consider x1 and s1 as 0, the maximum value of z will be 12. We can increase the value of z above 12 if we can increase the value of x1. So max z can further be maximized by maximizing x1. Let us now try to calculate the values of x1. Here the maximum possible value of x1 will be 6. As 6 minus 6 will be 0, x2 always greater than or equals to 0, x1 cannot go beyond 6. So the maximum value of x is 6, and according to S2 the maximum possible value of x1 will be 3. So if we increase x1 beyond 3, value of S2 will become negative. So S2 cannot be negative, so the maximum possible value of x1 will be 3 according to this constraint. So if we consider the value of x1 equals to 3, x1 equals to 3 will give the value of S2 as negative. So S2 cannot be, x1 cannot be 6, so the maximum possible value of x1 will be 3. So if we try to compare the second iteration of algebraic simplex method, so if we try to compare the algebraic simplex method values with the tabular simplex values, here 12 is the maximum value of x1, and 1 and minus 2 are the Cj minus Zj values. 1 minus 2 are the Cj minus Zj value with respect to x1 and s1. So we can further maximize as Cj minus Zj is greater than or equals to 0. So if we consider the iteration 3 for this, now the basic variables will be x1 and x2, as s2 becomes 0 when x1 is 3. So the iteration 3 for this will be x1 equals to 1 by 2 into 6 plus s1 minus s2, and x2 equals to 3 by 2 minus 3s1 by 2 plus s1 by 4, and maximum z will be 15 minus 3s1 by 2 minus s2 by 2. So the maximum possible value of z will be 15. If we let us check if we can further increase the value of z beyond 15. If we increase the value of s1 and s2, as here the values are negative, the value of z will decrease, so we cannot further cannot increase the value of z beyond 15. So the maximum possible value of z is 15. Let us try to compare the iteration 3 of algebraic simplex method using the tabular simplex method. Here 15 is the maximum value, and minus 3 by 2 and minus 1 by 2 are the values of Cj minus Zj. So when Cj minus Zj is less than or equals to 0, we cannot further increase the value of z. So Cj minus Zj should always be less than or equals to 0 for a maximizing problem. Thank you.